Hello, this is Tariq Rashid. I'm a professor in computer science and engineering department, University of Kurdistan Hawler. Today I'm talking about child drawing development optimizer, and I'm going to provide a step-by-step tutorial to explain how this algorithm works and how it can be implemented in normal life. The algorithm, before I explain it, I'll talk about the introductory background of this algorithm. And it is a meta-heuristic algorithm. There's also a case study that I'm going to show. And there's also a result and conclusion for the case study. Now, the algorithm was designed originally by Sabat Abdul Hamid and myself, Tariq Rashid, in 2021, and we called it a child drawing development optimization algorithm. This is a novel algorithm, which is inspired by the child learning behavior and cognitive development. Again, this algorithm is mainly developed for single objective. So there's still, we have to work with the multi-objective soon. The algorithm compared with other meta-heuristic algorithms, such as particle swarm optimization, differential evolution, well optimization algorithm, and gravitational search algorithm. Also, we compared with fast evolutionary programming. That's another algorithm. The algorithm outperformed all these algorithms when it was evaluated against them. We have at least one case study to show how this algorithm works practically, and we show you some results. Now, the basic idea of this algorithm, that human body, which was drawn by Leonardo da Vinci, he came with the idea of golden ratio. So the algorithm extracted the golden ratio idea and worked with the golden ratio. Now, the algorithm has some stages, maybe 5 stages. It goes through the drawing, which is developed through certain stages in the child. The age of the child includes 6 to 18 years old. So from 6 years to 18 years old, the child will evolve its drawing. So the first stage, we can call it the crippling stage. That's the first stage. This is the age in between 2 to 4, the child. And it's a young children trying to figure out his hands movement results. So it tries to draw a line or curves, and the child observes its line and curves which he or she draws. Then the next stage, which is schematic stage, the age of the child here is 4 to 7 years old. This stage also called pattern memory. Through this stage, the child's drawing are more standard and copied version of other drawings. So it tries to copy version of other drawings, and also takes the drawing from his surrounding environments. And it is the ability of the child to practice and to take feedbacks from his previous moves. What he learns here mainly few points. One of the points is controlling scribbling, which is the child is starting to have control of the scribbling in terms of hand pressure. So it's all about hand pressure here. Also, he learns shapes and enhances these shapes. So the child improves in the shapes, in size and perspective compared to real ratio of the object of interest. The third point, which learns, it's about pattern. So pattern or patterns come by learning to control the movement and direction to create shapes. Then the third stage is schematic stage. The child here has to be in between 7 to 9 years old. In this stage, the child will reach a level to draw a schematic of surrounding objects. And it repeats its drawing. And the children also, they will apply some skills here to draw the drawings. At this stage, then we come to stage number 4. That stage, the drawing realism stage. At this stage, creating groups or gaining up with other children is referred to as social independence from adult interventions. So children are getting more critical of themselves and their surroundings, in addition to paying attention to detail and making an effort to draw realistic and naturalistic drawing. And then in this, two features about this model is that they learn how to do object and people. You can see they learn how to do object and people. So appearing in the drawing to be realistic according to many factors, including the relation between the objects. So they make a relation between the objects and they see things, distance, perspective, size, and then they add also some imaginations here, creativity. And the last step is here we call it pseudo-naturalistic. The child will be around 11 to 13 years old. There's awareness in the stage is higher than ever before, though they are not yet an adult, still they are teenage, adding more detail and stepping toward self-centered approaches for drawing. So they will have a self-centered approaches for the drawing. So from these stages, basically we took or we extract our algorithm, and the algorithm, basically this is a flow chart for it. So this is the pseudocode. You initialize the child drawing. So each drawing is a solution, and we initialize all the parameters and golden ratio here. We use either equation 2 and 3. We come to them momentarily. And then randomly choose an index of pattern memory or memory of pattern. So here we try to calculate random hand pressure using equation 4, and then randomly choose hand pressure P1 length and P2 width, P3 for each drawing. If hand pressure was low, then update the drawing in this way and update the learning rate level and skill level. We use equation 6 and 7. Or if not, then we check the golden ratio and we compare it. If it's within that range, then we calculate the new drawing in that way, and we update learning skill and learning rate and skill rate, and that's how we work. We update the cost value. Then we find the global best, the best drawing, and iteratively continue until the criteria is met. So here is the flowchart for the algorithm. And the flowchart for the algorithm is, we start the algorithm, we initialize the parameter, we get the population randomly, and we evaluate fitness function for each drawing. And then we try to find the best solution or find personal and global best. Then calculate the golden ratio. And then we set the random memory pattern size and hand pressure. And then here there will be some checking, and I explain them bit by bit. And then we use our algorithm so that we can optimize and get the best solution. So without further ado, without talking too much about the theoretical part and the flowchart and the pseudocode that you can read them from the main paper, the original paper. Here I'm trying to give you a step-by-step case study implementation of the algorithm, which makes our life much easier. So assuming that we are in the first iteration, so initialize the parameters. We initialize the parameters. We have fitness function, which is x1 square plus x2 square. This is just for learning. You could have, now we have two dimension, x1, x2. You might have x3, x4, x5, xd. That's up to you. But now for this particular case, we have two dimensions. Now here, some initialization for lower bound decision variable. We start with 1, upper bound 10, dimension of the variables, 2 dimension, x1, x2, that's 2. Child level rate is 0.01. We started with that value. And then skill rate starts with 0.9. Pattern matrix size, PS, 4. And then creativity rate, 0.1. So here is the algorithm. Now we took 10 drawings, 10 solutions randomly. We have 2 dimension x1, x2, and we gave, these are randomly chosen, 5, 7, 3, 3, 8, 4, and so on and so forth. Now we try to find the cost function, 5 square plus 7 square, 74, and the rest will do the same. We found that some fitness is 842 in the first iteration, and the average fitness is 84.2, and minimum fitness 18, which is drawing number 2. That's the minimum fitness. 18 is the least fitness. Now we try also to get the golden ratio. The golden ratio, in the paper defined, we can use two equations, either x2, which is the second dimension, plus x1, which is the first dimension, over x2. That's one way, or x1 plus x2 over x1. So either way or either way is fine. We'll find the golden ratio for each drawing. Now you can see. So this table 1 shows you the fitness function for each drawing and also the golden ratio for each drawing. These are the 2 equations to find golden ratio. So either this or that, that's up to you. And you can randomly select them, it's fine. So they are found. Here the golden ratio. Now next, find the best personal best. or find personal best or the best personal, which is here we have global best. First time because it's a minimization, we assign it to infinity, global best. Because of the minimization, we think that our best is infinity, and personal best equals, or local minima equals fitness function. So now here the personal best is 18, which is equal to, we say that global best equal to 18. Okay, so that the global best equals to personal best. In the list, we'll see which one is the minimum. Then the global best takes the minimum value of the drawings that we have. Now, we have let me just improve this here, bring it a little bit down so that we can see it. Okay, now we have local best less than global best, then global best equals local best, or you could have global best equals the minimum of the minimum fitness value that we found. So we talked about the global best is taken as the minimum one, which is 18, which is the drawing 2. Now the first iteration finished. Now second iteration, we set an array of learning pattern. We'll take number 4 randomly. We take four values. We take the minimum 4 values, or the best minimum values in the list. So that's the list that we have. So we take the best minimum values. So we take PS1, X1, X2, 18, and 34, 80, and 85. These are the minimum we took them. 18, 80, 85, and 34. So these are the minimum of all these lists. So we managed to create pattern matrix. And then the algorithm says that set random hand pressure, which is, again, it's a random lower bound, upper bound. It happened to be 1 and 10. So we select 1 and 10. You can have minus 100 and 100. It's up to you. So we select randomly in between 1 and 10 for each drawing random hand pressure. So for each drawing randomly, we found them, and that's because we got it by this equation, which is the same random number. Lower bound is 1, upper bound is 10. Then here in this step, we have a new solutions, which is if xi, one of the dimensions of each solution, if it is less than or equal random hand pressure, then we use equation 5 to update position or the drawing, which only one dimension we change. X1 plus 1 equals golden ratio plus skills rate multiplied by best solution minus the current one plus learning rate multiplied by best solution minus the current one. Once we found this one, then we update level rate of the child and skill rate of the child, and they can be updated by using equation 6 and 7. So that is done, 6 and 7, and we find if this condition is not true, if x1, xi, one of them, then we try to use the golden ratio. Else, if the value of golden ratio is in between 1.5 and 2, if it's in between 1.5 and 2, we update our drawing by equation number 8, which is the next position or the next dimension of the drawing equals the uh, um, the matrix pattern plus creativity rate multiplied by global best. And then once we found this one, then we try to update child level rate and skill level rate in this way. So you can see the child level rate in equation 6 and 7 are different from equation 9 and 10, different ways. So if this condition is satisfied, then this is how we update LR and SR. Or if this condition is satisfied, golden ratio condition satisfied, then we update it in this way, 9 and 8. So in this case, we will have child 1 to child 10, and let's say this X1, this is greater than 4. This is cannot be, the first condition cannot be fulfilled. We go with the golden ratio, but the golden ratio is fulfilled. It's between 1.5 and 2, so it will be updated by the second condition. For the child number 2, 3, this one, X2, we take randomly one of them. So X2 is less than 5, random, that's applied, and then we update this child by first condition, while C1 by the second condition, and so on and so forth. So we try to find them. And if the two conditions are not met, so you wouldn't update. For example, I think child 8 and 7 and 9 might not be updated because both conditions are not satisfied. So this is another way of calculating. So that's for child 2. We use the first condition to update. These are the values that I put in. And then, so this is child 2, child 3, child 4. They're all first condition applied to them. Okay. Whereas this table shows you condition number 2 is applied on them, which is the golden ratio, and that's how updated. So it is, see, child 1, 5, 9, 10 are updated. 2, 3, 4 are not updated by the first condition, while 7 and 8 and 7 and 8, I think, are not updated. You see, you can't see them in this table, and you can't see them in this table, so they are not updated. Okay, 8, child 8 and 7 are missing here, and also are missing in here. So they are not updated. 6 also are not updated. You see 6 also. So 6, 7, child 6, child 7, child 8 are not included in the updates in this iteration because neither golden ratio is met or the random hand pressure is met. So the two conditions are not met. Now the update is done. You see the update is done, and you can see some of the fitness is changed and average is changed, and minimum became 13 now. It was 18 now. So in this iteration, we got the minimum drawing. The best solution is child number 2. It's changed to 13. Now, it's worthy to notify that if the improvement is not better, so we just leave it as it is. For example, let's say for any drawing, this is the old iteration and this is the new iteration. If this is not improved, if this not less than this, then we keep 18. But because 13 is better, so we can keep 18. We change the solution number 2 to 13. That's the fitness that it has. And we take the updated dimension for it. But let's say if you update child 2 and you receive, for example, 35, which is greater than 18, so we keep 18, and so on and so forth for all results. So basically, this is the results, and you can see first iteration and second iteration. Now, again, we tried to find we found the local best is this one, which is 13. Now, among all this, we tried to put this one, the best global solution. So the best global solution equals 13 now in this iteration, because it is less than all of them. Okay, and this one has been changed, that one has been changed, this one has been changed, this one has been changed, this one has been changed. So these are all changed. Now, here in this iteration, we have iteration 1, iteration 2, and you can see the sum is reduced and the average also is reduced and the minimum value is reduced, and we do minimization. So in iteration number 2, so the result is improved. Now, in conclusion, we proposed an algorithm for optimization. We call it child drawing development. The algorithm uses golden ratio principle to and replicates, it replicates the idea of cognitive development in the child. We also concluded that the algorithm iteratively improve its drawing or solutions, and we got better solutions in the later iterations. Now, to get further studies, so the original paper is published here, and there's a DOI for it. The tutorial is done by this paper, Azad, myself, and Shivan. Detail of the tutorial that I explained in this presentation. The detail is in the chapter, in Atlantis Press Springer, so you can go and check it. And at the end, I have I thank you a lot and appreciate you listening to this presentation. And if you have any problem, feel free to go through this link, which has all the code and the paper. And if you have any query, you can email me in one of these addresses. I can be found. So thank you very much, and I wish you all the best. Thank you.